Okay, here we go. This is the binomial distribution. Now, this is a probability distribution just like we've done before. If you were to add these up, they would equal 1, so it meets the rules for the probability distribution, and each probability itself is less than 1. So that is a probability distribution. This is telling us all the possibilities and their probabilities for this particular scenario. So there's some numbers here that we need to pull out from this distribution, and the first one is that n. N is our largest number in the possible outcomes. Okay, so n is 5, and that's just telling us that that's the largest number in the possible outcomes here of x. And x, again, is what can happen with the possible outcomes. And in this particular case, this is the number of times I make the traffic light in a 5-day work week, 0 through 5, with n being the largest number, 5. As I told you when I first talked about this, I had determined a long time ago that there was about a 40% chance I was going to make that light on any particular day. So we refer to that as lowercase p, and I'm going to just put 0.4. Okay, you can put the 0 there. I'll put the 0 there if you need it, but it's really just moving the decimal over twice for this 40% to making it 0.4. These numbers have to be given for you to proceed with one of these distributions. You have to know exactly what that probability is. This is what we call a binomial distribution because with this probability of 0.40, there's only one other probability. I don't make the light. What would be the probability that I don't make the light? 0.6. I'm going to call that Q. So Q is the complement of P, or 1 minus P is Q. Okay, so they're just they add up to be 1. Okay, they're complements of each other. So when you know what P is, then you know what Q is. Simple as that. There's the variable x we're going to use one at a time here as we need them and depending on what the question is. And I'll show you what that means in a little bit. But I'm going to start with using the variable x as 3. So I'm going to determine what the probability is that I make the traffic light 3 times in a 5-day work week. Now it's right here. It's this 0.230. But I'm going to show you how that is actually calculated, where that came from. Okay, and it came from knowing all of these values right here and using this lovely formula right here. Is there anything there you recognize? Yes, the combination, the C, the combination. So it's n and x where on the calculator and the work that you were doing before it was n and r. Okay, but we're still just using a number there for x. And we have n, we have x, we're going to do a combination. Then we have this lowercase p, which is the 0.40, and we're going to raise that to the x power. Then we have lowercase q, which is 0.6, and we're going to raise that to the n minus x power. Okay, so let me write out what that looks like. All right, so we have a combination of n things taken x at a time, which is 3. So we have a combination 5C3. We're multiplying that by 0.4 raised to the 3rd power and multiplying that by 0.6 raised to the n minus x, which is 5 minus 3, or 2nd power. Now let's see what this calculator will show us here. All right, so remember with a combination you put in the 5. Then you hit your math key, arrow over, and down. There's the combination. Put in the 3. And now I'm just going to proceed here. I'm not going to get an answer yet. I'm just going to multiply times 0.4 raised to, that's the caret there, to the 3rd power times 0.6 raised to the 2nd power. I know it always looks funny on the calculator, but that's that whole formula right there. Now I should get this number right here, the 0.230. Hit enter and you get 0.230. Yes, that's a good thing. Okay, so basically I just checked it to make sure that that was correct. And to show you that this formula can be used to get these numbers and how to use the formula. However, I'm going to show you an easier way, okay, with the calculator, and you don't even have to do all that. This formula is on the sheet. Okay, it's somewhere on that sheet. But what we're going to do with the calculator formulas, if you will, are not on the sheet. So that's why you have to take notes on the calculator so that you know what to do on the calculator. All right, so I'm gonna first just show you something. So just watch this little demonstration. So I'm gonna go to this see this key that says vars. Above it says distribution, D-I-S-T-R. Okay, we're working with distributions, so we're going to go there. So second vars gets me with all these distributions. Okay, we're going to look at the first two later on, normal distributions. I'm going to arrow up. Okay, arrowing up, I'm going to go to the binomial. There's the binomial distribution. Okay, it's called a binomial. It's B-I-N-O-M, and the probability density function is what the PDF stands for. Okay, so when you do the binomial, okay, I actually have it listed down here in this example. You are always, when you do a binomial, PDF, you're always listing first n, whatever n is, then a comma, whatever p is, then a comma, and whatever x is. Okay, so these are what we call the arguments. These are the numbers that you put in. So similar to putting in list 1 and list 2. This is something you need to write down because when you're doing this on your own, you will sometimes forget what you're supposed to put there. I will tell you, if anybody's sitting right here at this point on your calculator, before you hit enter, if you hit the plus sign on your calculator, you might have the software that tells you what to put in. Number of trials, N, P, and X. All right, so I'm putting in N, which was 5, comma, P, which is 0.4, comma, 3, which was my X that I was using for this problem. So when I hit enter, I should get that same value again. All right, so this is using a distribution function. Okay, I'm going to go over this again. If you didn't catch it the first time, this won't be the only time you see it. All right, so I want to use that distribution function, though, in a list. Okay, so everybody in the room has experienced the list functions now, so you should be good with this. Yes? Okay, I'm going to talk about it again, so everything's going to be repeated. So I want you to go to list 1 and put in the 0, 1, 2, 3, 4, 5 on your calculator. Everybody should be able to do that. We've been doing that for a while now. Zero, 1, 2, 3, 4, 5. Everybody there? Now we're going to go all the way to the top of list 2. All the way to the top of list 2. I actually have the steps written here. To get to this binomial, you hit second and vars, arrow up till you get to binomial PDF. We're going to hit enter, and this is like going in that formula spot where we're going to actually get all those values from that table. Now I'm going to put in n, which was my largest number, 5, comma, I'll do it again in a minute, 0.4 was the probability that's given, comma. Now all of my x's are in list 1. So instead of putting in an x, I'm going to put in a list 1 here. So second and the number 1. So it's going to use each one of these x's in list 1 to calculate the binomial probability, and they should all come out to be matching with this distribution that we have. Okay, so I'm going to do this top of the list too again. I'm going to go up there and clear it and go and tell you, run it through one more time.
Thank you.
Okay, so the steps are written here. So I'm going to go second and the key that says vars, second vars. Then arrowing up until I find the binomial PDF. Okay, then you hit enter. Then you put in your N, 5, and a comma, your P, 0.4, and a comma, and we're using list 1 for our X, so second and the number 1. Hit enter, and again, there they all come out. I will. Question.
For entering X or list 1?
Because we're doing the whole table and all of the X's are in list 1, we're going to put in list 1. If you were just doing an individual probability like I did before, then you put in the X that you need. Okay, and so we're going to see this in both ways today, where you need to do the table and where you need to find an exact probability. Okay, but getting comfortable with that binomial function is what I need for you to do right now. All right, I'm going to clear this out and show you one more time. All right, second key, vars key.
Oh, wait.
Second vars. Arrow up for binomial PDF. Hit enter. And now we're going to enter in N, which is 5 in this case, comma 0.4. Remember the comma is above the number 7. And another comma. And second, list 1.
I did the wrong thing. I wasn't doing binomial.
Okay, so what this did was verify this table. And this is how you get any particular table. Okay, the key is to know what your N is, and also one of the most common errors when you're making a table on your own is to leave out 0. These are events in their probabilities, and in the case of a binomial, 0 times can happen. Okay, we could just not make the light at all in a 5-day work week. That can happen. So 0 is always one of the values in the data set. All right, let's look at some of the questions that I have written down here at the bottom. You can use the table that you have on your calculator, or you can use the table that you wrote down. If you wrote this table down, which I asked you to do, to find most of these values. Okay, I just want to remind you how the table works. All right, so what is the probability that I make the traffic light out of my neighborhood exactly 3 times? Well, we actually have just done that. 0.230. So if the table's made and you're just looking at the table, you can just write it down. You don't have to do the calculations after you've done the table. You have all the numbers right there in front of you. So a lot of times making that table, even if I don't ask for it, it's useful because you can see everything that's there. All right, what's the probability that I make the traffic light out of my neighborhood at least 3 times? What does at least mean? 3, 4, 5. It's a probability when X equals 3 and 4 and 5. Okay, so it's the 3 at the bottom there. So again, you could just add them up. So it's the 0.230 plus 0.077. I'm just getting this off the table, 0.010. And just add those together, and you'll have the that total. $317. So the probability that I make the traffic light at least 3 times is 0.317. And then less than 3 times. Less than 3 times is 0, 1, 2. Hey, what's an easier way I could do that? 1 minus the 317. I just did 3, 4, 5. So the complement of 0.317 is going to be 0, 1, 2. So 0.683. So understanding that whole idea that the table adds up to be 1 and what you need to do and what you need to put together, what you could subtract from, it can make it a lot easier, the whole process a lot easier. All right, so these notes are going to be available to you to look at again. So I'd like to move on to a different example. Okay, we ready? Well, it's all about the wording of the question, okay? And sometimes you have a table, sometimes you don't. Okay, so here we don't have a table given, so we're going to have to come up with these probabilities ourselves. Okay, we're talking about surgical techniques on 7 patients. You are told there is a 70% chance of success. Find the probability that the surgery is successful for exactly 5 patients. All right, when you have a problem like this, the first thing you need to pull out are N, P, Q, X. What is N? 7. All right, what is P? 0.7. Okay. What is Q? And for this first question, X equals 5. For the first question, X equals 5. Now, since this is an exact, we don't necessarily need to see the whole table. So since we don't need to see the whole table, let's practice just getting one probability here. All right, so this is going to use that binomial key again. Second vars, up, 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 up. Enter. Now we put in N, which is 7, comma, P, which is 0.7. Is that correct? Yeah. Both of them are 7? Okay. And X. We actually don't need Q for the formula, for the calculator formula. So, comma, 5. So this is the number of trials, N, the probability, P, and X, the number that we're actually asking the question about. So hit enter, and we get 0.318 rounded to the thousandths place, 0.318, or 3 significant digits. If you know how to do this on the calculator, these things become very simple. Can be very, very simple. All right, so now what does at least 5 mean?
1 minus
5 and above. So we've already done X equals 5. Okay, we have X equals 5. So we need X equals 6 and X equals 7. We need those 2 probabilities. Okay, so now I'm just going to do this again. Good practice using this function here on the calculator. I'm going to do it again. Now, I will tell you, if you know how the calculator works, you can do an entry over again. I'm trying to point down here to above the enter key is an entry. So I can go second and enter, and I'm putting the whole function back in. But instead of 5, I need to arrow over and change that to 6. So all I did was change the X to 6. Okay, so I'm doing the binomial PDF, 7.7 and 6. And that gets us 0.247. Actually, the probability of X when X equals 6. I don't want to put an equal sign there. Yeah, and then we're going to add the 3 of them up. Okay, so now we've got, okay, let me show you that second entry thing again. Okay, the enter key, second, and the enter key puts the function right back in that you just did. And then you could change the last number. this time to 7. And 0.824. And then we add the 3 probabilities up. .647. So we did exactly 5. We did 2 more and got at least 5. So I had to do the function on the calculator 3 times here. Just 3 times. What about less than 5? 1 minus this number. Okay? So we've done at least 5, and now we want less than 5. You see the pattern that I'm working with here? And now I want everything that's below 5, so all I have to do is go 1 minus this number. All right, one more time, though, I would like to show you how to use, I'm going to do this next problem, but even with this one right here, if you wanted to see all the probabilities, you could still make yourself a table. Okay, so I want to talk about that again to make sure that we're clear about how to do that. Over here in list 1, it went through 5. Now I need it to say 6 and 7. Okay, so you make sure that you have all the values in list 1. And then I'm going to run through that how to put that binomial up there one more time. So it's second vars, up, 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 enter. Our n was 7, comma. Our p is 0.7, comma. And again, this time my x's are in list 1. So second, list 1. And there will be all of those probabilities. Now, please notice that we've got, some very tiny ones up here. With that -4, that just means the decimal is moved 4 places to the left. So there's 3 zeros in front of that. So remember, you might have some very tiny ones. You might have some that are it depends on the size. As n gets larger, you get more of these really small ones. And so arrow down here, you'll see what we did. We got that same number for 5 and 6 and 7. You can kind of see how these numbers are getting larger and then getting smaller again, similar to the other distribution we looked at. So if you needed to see all of them, that's how you see all of the possible probabilities. If you just need an individual one, then you don't need to work with the list. It just depends on what the question is asking. It's going to be a little later in the next lesson next week when we talk about outliers again, and we'll want to look at the whole list of possibilities then. But right now, today, we're just going to practice getting these individual probabilities and some multiple probabilities that we add together, just depending on what the question is. All right, so let's look at one more example. And this is 54% of men consider themselves basketball fans. If you randomly select 10 men and ask each if he considers himself a basketball fan, find the probability that the number who considers himself a basketball fan is exactly 8. Okay, so what is n? 10, thank you. What is p? 0.54. Don't forget the decimal. Okay, we don't really need q. This first one, x is going to be 8. So we're going to get the probability when x equals 8. That's how that should be written. All right, here we go. Second, vars, binomial PDF, enter, 10, comma, 0.54, comma, 8. Okay, 10, 0.54, 8. 0.0688. At least 8. We've done 8. What else do we need? 9 and 10. So probability when x equals 9, probability when x equals 10. Again, you could save yourself looking for that binomial function by going second enter, and the same data comes back up, same entry. Change that last number to 9. .18 and 0.18 with the rounding. Same thing again. I'm going to go second enter and change 9 to 10. Three significant digits, and then add the 3 up for the total here, at least 8. And what are we going to do for less than 8? Subtract from 1. All right, so if you check out some of the problems in your book today, a couple of places they ask that you use a table that's in the back of the book. You don't have to do that. I want you practicing on the calculator. Okay, so if it says use a table, don't worry about it. Use the calculator. If it gives you a probability P and they say it's 1/3, okay, what does that become? You need a decimal, so 0.33 will be fine for that. Even add another 3 and you'll be more precise. So they're going to give you some fractions in a couple of places. Just turn them into a decimal number and put that in as your P. So there's a little bit of reading that you should do to just be familiar with what they're talking about with the binomial situation. The fact that we only have 2 possibilities that can happen. Either the person is a basketball fan or they're not in this one. In this one, either the surgery is successful or it's not. In the traffic light, I make the traffic light or I don't. If there's a third choice of what could happen, it's not a binomial. Okay, the probabilities have to just be 2, and that's where the bi part of the binomial comes in. It has to only be 2 possible probabilities for that situation. So there might be some questions like that. If you want to just get into working out the numbers, that would be a good thing for you to practice. And then, I'm going to do another example on Friday and give you some more information about doing the same thing, give you some more time to work on it. Okay, so the key here, especially with the calculator, is practice. You need to practice using the calculator and getting the correct answers. So if any of this that you want to, you can see this sheet with these notes on it and see if you can get the same answers again if you've been struggling a little bit with the calculator. But everything else, right now I want you practicing on that calculator.